founders of Netreo. Today, we're going to talk about 5 ways you can use to improve your DevOps monitoring and management. During the presentation, if you have any questions, please type them into the question section of the webinar interface, and we'll be sure to address them as we go along. So some of the most common challenges we hear about from customers are things that might be all too familiar to some of you. One of the most common is that teams lack visibility into the whole environment. Many conventional management tools are slow to adapt to the rapid changes in deployments that are key to DevOps, and this can lead to blind spots. And of course, if the teams don't share a single view of reality, you can get finger pointing between the teams, which can cripple your resolution times. Visibility often suffers when it's difficult and labor intensive to manage. So if a manual process is required to add monitoring onto new systems, there's just no way it can ever stay up to date. Often, this lack of an up-to-date view across the organization leads teams to implement their own point solutions. And the more tools you're dealing with, the more likely they are to contradict each other, to say nothing of the increased admin and training burdens and the communication issues that that causes. Also, if we don't have good hard data about how things are actually performing, it's difficult to avoid slowing down response times or oversaturating infrastructure, which can damage reputation and add unnecessary cost. DevOps should really be helping your organization and not causing more problems. So how do we get here? The State of DevOps report told us that high-performing organizations resolve production incidents 168 times faster than their peers, with the median high performer having an MTTR measured in minutes, while the median low performer had an MTTR measured in days. The top 2 technical practices that enabled fast MTTR were the use of version control by operations and having a telemetry and proactive monitoring in the production environment. So a key finding here is the realization that DevOps often focuses on producing applications faster and not on performing or promoting after deployment operational visibility. And that can really hurt us when it comes time to deal with critical failures. So if we can reduce MTTR by having telemetry and proactive monitoring, why don't we have that already? It's because we're stuck in firefighting mode. If development isn't thinking of the monitoring part of the equation during the development cycle, they're crippling operations and as a result, MTTR. Reactive alarming means that we're not detecting unusual but significant behavior and we're not finding problems before they start impacting users. Lack of automation is also a big factor because the admin and training burden of running multiple monitoring platforms means we're wasting a lot of time and we're probably never keeping up with the speed of DevOps deployment. It also means we're manually intervening every time there's a problem. Most platforms suffer from slow, cumbersome reporting and little ability to customize or automate it. And this leads to a lack of real data to make planning decisions or efficiently scale. So the first and most important thing we want is telemetry. So how do we get telemetry? Telemetry is really just data, but it's data that you can use. So if we're burying important pieces of information in a petabyte of log files, it's not helping anyone. So the most important step in improving DevOps visibility is to make sure that you're collecting the right data. And the best way to get monitoring in operations is to start by designing, planning, and building it in development. If we can make it as easy as possible to get that data into the monitoring platform, that's the first step in getting development on board. This means we need a flexible set of APIs to push data to and easy ways to manage the configuration, preferably fully automated ones. If we make it too difficult to add this visibility into the applications, the developers will resent having to do it, and it's going to slow down the deployment speed, which is the opposite of what we want to do. But if we make it easy enough, the developers can use this data to help them debug and optimize as well, and they're going to embrace it, which helps everyone. So an important way to make this data really useful is to get a single view into the environment to make sure nothing gets missed. And this has really been the primary goal of OmniCenter since the beginning. So by integrating application and system level metrics into a single user interface with consolidated reporting, you're really enabling the system to detect correlations and empowering your operators to better find the cause of problems without having to go on a scavenger hunt through multiple systems. So we need to get beyond that up-down monitoring and really get into telemetry. And this means we're going to need good visibility into the entire application stack, including the user experience, applications, devices, systems, and the underlying infrastructure. So to get there, we need to make sure we can see into the application. And this lets us detect sudden changes, what we call anomalies, that can tell you when something isn't working right, or when a problem exists only at scale, or when a deployment breaks something unexpectedly. A simple test is usually pretty easy to create for applications, but if you can work with development to get a very specific test case built into the application, and what that test case is, what function it links into, and what method should be used to collect that data, continuous testing is a lot easier. So if we build some hooks into the application that can show us where and how something is going wrong, we can get much deeper visibility very easily. And then we can push that data into OmniCenter via an API. So it's as easy as making a web call, and we can easily integrate tests that are too deep to run from the outside into the main operations dashboard. So one example of this is a customer who set up their application so that if a certain internal function call took longer than the designed number of seconds, they could push that alert directly to OmniCenter, so the operations team would know about it, and then they could get long-term reports about how often this was happening. And this let the development team optimize the way the application scaled and gave them good historical insights into how those optimizations then improved performance over time. A key to this is to make sure that DevOps visibility is an asset to all the teams. So we really want to make sure that the monitoring system can stay up to date, whether we're doing 50 deployments a day or 1,000. And really, automation is the only way to do that. So if we link provisioning into monitoring using those web-based APIs, as we deploy new systems, they can automatically be added into monitoring. So we can push in new systems, via the API if we want to, or have OmniCenter auto discover those systems via the API where those exist for things like cloud-hosted systems, AWS, GCP. Or even automated systems like Docker or Kubernetes, things like that. But then we can drive that configuration forward using rules to define things like category, business workflows, and templates that can control every aspect of the monitoring configuration. So we don't have to manually provision those systems. They can automatically be detected and automatically added in and have all the correct kinds of alerts set for them, have the right thresholds applied, have the right settings and monitors applied. So we know that every time a new system comes online, it's being monitored correctly. You can even link deployments in with automatic maintenance windows so that when I'm doing maintenance on my systems, it can automatically be reflected in the monitoring system. Less time spent putting new systems into monitoring and making sure the right settings are applied means you have more time to focus on moving the organization forward. So we use a rule-based auto configuration system to automate configurations within the tool. And auto configuration comes with a set of rules that can really help you get started, and you can easily customize or create new ones to fit your environment. So you can use these kind of rules to set device attributes like category, site, application groups based on any device criteria. So things like which processes are running, what ports are open, what the device is named, or even SNMP values. So we can make sure that there's no manual step in the provisioning process, and we can ensure that the right devices end up in the right reports and that they always get all those settings applied to them automatically. So these are automatically applied to new devices as they're discovered, but we can also reapply these whenever we want to. So if we want to make sure that everything stays configured based on our rules, we can enforce that. The way we do that is by applying templates to the system. So OmniCenter dynamically applies all of the relevant templates to the devices based on any of those device criteria. So, name, location, running processes, listening ports, anything you can detect on the device can drive into a template setting. And multiple templates can automatically be applied to that system, and they'll cascade down onto the system. So different settings from different levels of templates will intelligently be rolled on. So for example, a SQL database coming online would not only get all of basic Windows Server settings, but could also get SQL specific application checks and settings, might even get some special settings applied like different latency thresholds based on its geographic location. You can align those templates with the monitoring plan to make sure that they get appropriate escalation timings and have them predefine things like authentication, escalation, even which automated actions to take as the result of an alarm. So it's really designed to be flexible enough to meet the needs of and scale to a fully deployed DevOps environment, while still being simple enough for a small enterprise IT department to use without a lot of training or dedicated personnel. Now, one of the keys to improving visibility is to detect unusual behavior instead of just relying on static alarm settings. Um, a great way to get proactive with monitoring is to get out of firefighting mode and start on preventing the fires in the first place. So we use a technology called anomaly detection to do that. And anomaly detection is basically used to find changes in application behavior. So I can apply this almost anywhere to CPU, memory use, running processes, even log messages. So if the application suddenly goes from 10 login failures an hour to 1,000, maybe that last deployment didn't go as smoothly as we thought, and now we have a starting place to troubleshoot. OmniCenter automatically builds a baseline behavior model using the large volume of historical data that we retain. So it automatically adapts the baseline as your environment dynamically changes and evolves. Anomalies can be detected based on changes in baseline behavior, looking at time of day, day of week, or even hour by hour. And this allows us to find unexpected impacts, like a software change causing an impact on a backend SQL server. So one example is a customer of ours discovered an issue where at 10 a.m. on a Wednesday, the database would normally be running at 50 or 60%, but suddenly this day it was running at 15%. When they looked into why, they discovered that there was a software push right before the change, and it turns out that a user interface change that was made during that software push was making it confusing and customers weren't able to complete their transactions properly. So that sort of anomaly is the kind of unusual behavior that would never trigger a static threshold, but in this case, it revealed a problem long before they noticed the drop in orders that would have resulted. Another great way to get control of your monitoring is to integrate automation. So automation comes in a few different flavors, and the first place to look at is automating the response to alerts, so we can eliminate the need to send a notification at all in many cases, or eliminate any kind of manual intervention sometimes. So the idea here is that we can automatically link in things like CLI commands like SSH or PowerShell, or we can use APIs like webhooks. So we can use the monitoring system to automatically do things like restart ports, deploy additional containers, retest applications, or even just connect to a server and dump real-time diagnosis in response to a particular issue. So I don't have to wait for the problem to recur multiple times. I can actually have the system go in and grab the data, even if it's something that only happens for a few seconds at a time. Now, some people are uncomfortable with automatically executing commands. So what we did is we built it in so that you can control those commands manually through operator intervention if you prefer. So if we want to add a click to restart server function directly into the web interface of the monitoring system and then limit that access to just administrators, there's an easy way to do that. One customer even set the system up so that it restarts the server automatically after hours, but only notifies the NOC during business hours, and then they can make that decision when they're available. However, keep in mind that if you're automating the response, maintenance windows become absolutely critical. Otherwise, a scheduled software upgrade might not go as you expect, as your monitoring system starts taking action in the background. Nothing's more frustrating than pausing an application service for a deployment and then having the server suddenly reboot because the monitoring system was instructed to do that. So if we create those maintenance windows, we can make sure that the monitoring system isn't going to be taking any action in the background that might work against us. Now, one of our other recommendations is to monitor the dev environment. And this usually causes people to go, wait, what? But no, really, we want you to monitor the dev environment. And there's several good reasons to do that. It really allows you to engage development early in the process to make sure they're considering the operational side of the equation. And it allows you to detect performance disrupting changes early on. It also allows you to get good baseline data from the application so you know what the impact of user load is and what might need code optimization. You do have to be really careful with how alerts are handled and where they go, but this can easily be managed using incident management rules. So we can create a rule, for example, that takes any alerts coming from development servers, category, or any device that has dev or test in the name, and reroute those to a specific mailbox that doesn't wake anybody up, but still gives you a place to go track and see issues. Or it can even open up tickets in the bug tracker for them instead of opening them up in the ops ticketing system. You can also just suppress all the alerts and schedule history reports to go out daily so you can keep informed without being bothered. It really makes transitioning into production monitoring a lot easier, as any issues with monitoring or telemetry collection are going to be detected prior to deployment. So if I know, for example, that my development system is being monitored and dev is working on a new version of the software, and suddenly my application metrics on the development system drop into the toilet, I know, okay, you guys maybe want to look at how that page is being created or rendered, as it's 14 times slower than the production version, and we don't want to deploy that until that's optimized. So one of the other tips that we like to give DevOps customers is to make sure that you're monitoring from where the users are. So OmniCenter integrates a network of remote reflector systems that allow OmniCenter to monitor public-facing sites from all around the world, even if your OmniCenter is on-premise. And so Netreo provides a network of these for public-facing applications, or you can deploy your own for private cloud monitoring. You can also implement OmniCenter fully in the cloud and monitor from there and get access from anywhere, or deploy remote collectors in as many different clouds as you like and keep your OmniCenter on premise, whatever makes sense for your particular architecture. And this is fully integrated into OmniCenter's configuration interface, so there's no special setup for it. I can literally just say when I'm creating an application test where I want that test to run from and select a local source or select a remote source. And this also allows me to test from multiple locations simultaneously, so I can get deep visibility into application performance. And this is all testing at the highest functional level possible, as it's a fully synthetic transaction. Now, one of the other keys to really making DevOps monitoring successful is to make that data available to everyone in the value stream. So everyone shares a common view of reality, and that aids in communication and demonstrates transparency, which enhances trust. So a key element to making this successful is to make it easy and quick to access so that teams don't feel like they need to have their own monitoring tools, which creates a lot of alert noise and redundant effort, as well as adds to, admin support, training, and maintenance spending issues. So if the audience that is going to be getting this data is non-technical, and in every company there's always some non-technical people that we have to keep in the loop, don't hesitate to simplify or abstract the data into easier to understand formats. So we do this with our business functionality or business workflows, which allow you to group entire applications and all its component parts into a single percentile score. And then I can share that data using a number of different methods, depending on what's right for my environment. So I can use things like APIs, common share pages, intranet pages, unauthenticated pages, and information radiators. And an information radiator is just a system that's designed to display status data in a public area. So for example, a monitor on the wall of the hallway everybody walks through. You can display metrics using things like custom dashboards or business workflows in order to share useful data with the team. So certainly current incidents and things like that, but also useful operational metrics like response time, transaction velocity, system or application status. Um, it also allows us to demonstrate our DevOps chops because everyone on the team and even from other teams can see that we have nothing to hide from our visitors, from our customers, from our stakeholders, and that we have nothing to hide from ourselves because we're acknowledging and confronting problems. So if we make those simple to understand, they're much more likely to get used. And so what the business workflow functionality is designed to do is to group arbitrary systems together so I can see all of the different parts that are required to make an application work, like databases, storage, load balancers, clusters, microservices, containers, and I can group those into a single percentage metric that can be monitored and trended over time so I can detect anomalies or manage or report on things like service levels. You can control how much each monitored item is weighed, so only key metrics or services on the system are counted. That way, the numbers reflect the reality of how the applications are doing, and systems can be part of multiple groups. So I can have one group for storage, for example, that the SAN team is focused on, but the storage arrays can also be part of each application group that depends on them. So the app teams can see when a problem might be coming from storage, which cuts down on resolution time. I can also combine multiple groups into aggregate groups. So for the CIO's dashboard, for example, she can have a single metric for each major line of business or area of responsibility that just says network, security, systems, remote offices, and know immediately if everything is good or if something's being worked on. OmniCenter also integrates this into auto configuration. So grouping these systems into the right business workflows can be done automatically, and maintaining that going forward can be done without additional admin overhead. So now every time I add a new system that has the application name Ajax in the title, it goes into my Ajax business workflows group. And then as those systems are discovered or they're dynamically spun up or taken down, that group is always up to date with all of the different systems that are part of that application. We can also use tags to identify key portions of application delivery. So I can make custom dashboards or on-demand reports that only take seconds to pull up, where it might once have taken hours to have an engineer run reports on things like pulling all the CPU utilization on all the systems that are running a particular service, or pull bandwidth on all the ports that affect a particular cluster or a VRF group. I can now render that data in real time in just seconds by using tags. So a small time investment in tagging things or in creating rules that apply tags can make generating these kinds of complex reports effortless. And of course, you can automate these so reports get pushed out daily, weekly, or monthly with no extra effort. I can even have OmniCenter that if it's doing configuration management on devices, automatically tag interfaces based on strings found on those interfaces. So for example, anything that's got a description that indicates Ajax application can now be automatically tagged with that particular application. And then as new devices are discovered, these rules can just continually be applied so everything always stays in sync. So having good telemetry makes deployment safer. So if I'm monitoring the applications throughout the development process, like we talked about, I have a pretty good idea of what to expect even before I deploy the application. Now, if I'm monitoring the logs and looking for anomalies, I can also find it easy to detect when something goes wrong or something unusual changes. It also allows us to make sure that the deployment didn't break something else. So comprehensive telemetry means that I can be sure that when I deploy something, it's not creating collateral damage in other systems that I didn't think would be effective. So, I mean, we've seen more than one deployment happen that monopolized a resource that no one realized was being shared by another application. And this is more common at larger organizations where you might have multiple development teams working in parallel. Telemetry data also provides a lot of decision support metrics. So this allows us to do things like predictive capacity planning. So by knowing in advance what the long-term trends are, even when they're not obvious, we can prevent performance impacts before they even happen. And of course, we can automate these reports to make sure that they always go out, which improves trust and communications throughout the organization and saves a considerable amount of operator time. OmniCenter uses a make any view into a report model. That means no special training or scripting is required to get exactly the reports you want and sent exactly where you need them. The next key point is to make sure that you're engaging the right people at the right time. And this sounds obvious, but you'd be surprised how often it doesn't happen. So if you're not going to react to a notification as soon as it comes in, you shouldn't be alerting on it. For example, if you're getting alerts when hard drives reach 90% utilization and then you're ignoring them because that's not urgent, two things are going to happen. First, sooner or later, you're going to get an application failure because you forgot to circle back on that alert before the drive filled up. And second, you're conditioning yourself and your teams to ignore those alerts, and someone someday will inevitably ignore the wrong one, and you're going to have a major problem on your hands. So instead, use reports so we can be kept up to date on things that may not need to get folks out of bed, but I can still stay informed on what the status is. So a nice email in the morning showing me, which hard drives have the least space free, for example, is a lot nicer than being alerted every time it happens and then ignoring those alerts. So I can set my alerts only when those are truly critical. But if I get those reports in advance, I can take proactive action before I reach those critical thresholds to make sure I get to sleep through the night. A key success factor is to schedule and automate those reports though, so nothing ever gets missed. And I'm not depending on some poor soul to take every week, time out to run the report and send the report. And that's surely going to get skipped when the team gets up to their necks in alligators, or when the designated engineer is on vacation and the person covering for him has no idea how to work the reporting software. So let's look at a couple of examples of what we call actionable alerts to see what's really actionable, because it isn't always as obvious as you'd think. So for example, a high CPU utilization alarm, is that an actionable alarm? Well, it might be if the CPU has been stuck there for a while, and we can set a delay for those types of alerts so it doesn't generate an alarm until it's been over 90% for some length of time. So if the SQL Server pegs the CPU, that's pretty normal and I don't want that alarm. But if it's been pegged for 30 minutes, I probably have a job I need to go kill. What about a switch port going down? So is that actionable? Well, if it's plugged into something important, generally yes. So this might be a good candidate for an immediate alarm. But what if that port is part of a port channel, or it's just one server in a large cluster? So that might warrant a different priority or a different method of notification that doesn't require a drop everything and fix this type of response. What about the website going down? Well, that's generally a big yes, but you want to make sure it's down from outside the environment and not just, for example, a VPN failure to the VPC from the inside. So using things like application checks launched from multiple remote locations can help you assess the seriousness of the issue. And we make it easy to do that from anywhere, whether it's your data center or your private cloud or our cloud. We also build in a bunch of tools to help optimize the alerts, which will help you to identify what I like to call the noisy birds. So these are the few configured monitors or thresholds that are responsible for a disproportionate amount of alerts, or those where an adjustment to the sensitivity alarm is probably required. So I can use things like template baseline reports to see exactly which alerts are being generated by the configuration templates and make changes to them directly that can then be automatically rolled out to all the devices where that template is applied. So it gives me a great way to see, this particular template has a setting that's a little too sensitive. It's generating most of the alerts that I'm seeing. And then I can go out and either address the cause of that alarm or I can adjust my thresholds to compensate. There's also some other specialized reports like notification summary, and these are helpful to see exactly what alarms are going out and to get a count of how many alarms are coming from each of the different devices or from each type of service check or threshold alarm. So I'd like to take just a moment to talk about who we are for those of you who haven't worked this before. Netreo is in the middle of our 20th year, and we've been profitable since year one, providing easy to use and comprehensive network management systems and platforms for private and public enterprises around the world. We won Monitoring Product of the Year from Network Computing UK 4 years running now, and we made the Inc. list of fastest growing companies for the last 2 years as well. Last year, after 18 successful years of being internally funded, we did a private equity transaction to gain additional working capital and resources, as well as access to some very experienced business experts, allowing us to grow even faster. And our track record in enterprise business speaks for itself with customers like Wells Fargo, Aon, Partners Healthcare, SpaceX, and many others, with whom we've maintained more than 95% customer retention since day one. So now I'd like to take a few minutes to address any questions you may have. So please enter those into the GoToWebinar interface if you have not done so already. And I'm going to launch a poll now. So if you'd like us to follow up with you with specific information or discuss your unique environment, you can let us know that way and we'll be sure to get in touch with you privately. So the first question here is, how far does OmniCenter scale? And that really depends a little bit on how you're implementing it. OmniCenter is available as either a virtual appliance, a physical appliance, or as a cloud deployed appliance. So if we deploy that, it really depends on resources. We have hardware appliances in different sizes that go anywhere up to 25,000 devices in a single chassis. And then you've got the option to cluster multiple chassis together to scale to a virtually unlimited size. With virtual systems, you can generally scale those up to 6,000 or 7,000 systems, just depending on resources. But you can also deploy remote collectors to scale out. So what we call system engines that you can deploy to add additional horizontal scaling if you have large amounts of logging data or large amounts of things like net flow data, or even just remote locations that need separate data collection for latency purposes or for access purposes. You can scale those out horizontally, and then that distributes the load across multiple appliances as well. The next question is, how is pricing for OmniCenter handled? So we don't charge separately for different kinds of monitors or for different levels of monitoring. A lot of companies in this space have complicated models that require you to count the number of hard drives separately from the number of servers or the number of routers or the number of access points. What we've tried to do is simplify the model. So our pricing is based strictly on the number of devices, and then any one of those devices can have an almost unlimited number of things being monitored on them. So multiple different applications, multiple services. I can monitor as many switch ports as I want on a single device. We basically count them as logical operating systems. So a host running 10 guests would count as 11 licenses. On the other hand, the stack of 10 switches that manages a single logical entity counts as a single managed device up to 1,000 interfaces. So it's really designed to be able to scale pretty well. It'd be easy to scale and figure out when you need to add licenses or when you can reduce the number of licenses you have. Okay, thank you for joining us today. I hope you've learned some useful tips to help improve DevOps visibility in your environment. And as always, if you have any additional questions, please feel free to contact us at info@netreo.com, and we'll be sure to get back to you right away. Have a great rest of your day, everyone.